Go.
They both are equal.
So for number 2, we're gonna have a frame, and you're gonna have two support, a pin and a pin, and not joint skill. So you know when you have a 2 pin, you're gonna have 4 reactions, and we only have one part. So 4 minus 3 indeterminate to the first degree. So we can just take a moment here to find all the reactions. So what we're gonna do? So you can remove this. You remove the pin and replace with a roller. Is that how to do it? Wait. Okay, yes. So you remove this and you put a roller here. After that, just remind you, you reduce the x-axis. This is A, this is B. You remove this. So later you're going to put it back in the unit load. So for this one, right now you have a roller, you have a pin. So 3 reaction and you have 1 part, so it's 3 equal to 3, 0. So for this one, you can take a moment to find the reactions. So for reactions, you know how to do it. So I'm just going to give you the reactions. You're going to do the moment yourself. You're going to have 19.5, 55.5, you're going to have 18 cubes. Yeah. So you have this reactions. This reaction is for the real number, for the real beam, the real numbers. Right now, we have to do the unit load. Like I said before, you replace a pin with a roller, so you reduce the x-axis. So for the unit load, because you remove it, so you have to put it back. So you put 1, right here. So this is all you have. Because for unit load, you're going to put a 1 unit load here, and all the force, you just remove them. So that's what you have. You do the same thing. Take a moment at this point. You're going to find the reactions. But for this one, you only have 1 force in the horizontal axis. So for the y, you're going to have 0 and 0. And for this one, they have to cancel out each other. So you're going to have another 1 here. So this is your unit load. This is your real numbers. So next thing, you want to find the moment equations. So you can find this. Yeah, you have to find the moment equations. Looking at this frame, you have a straight member going up. You have distributed load. You have point load. That's it. So for this one, you're going to have 3 things. You can have moment 1, point load at the same point, so it doesn't matter. So you have M2. See, this thing is continued to the end, so you only need 1 equation here. I mean, you can do it like this if it's confused you. You do this. First part, just straight line up to here. And you're going to have point load. I mean, you just do this, make it like a straight. So you're going to have 18. You're going to have distributed load. And you're going to have another distance from here, same distance, like this. So if you have something like this, how many equations you're going to have? So you're going to have 1, 2, make it easier, go for this side. So you just do this. 1, 2, 3. In same for this one. You have 1, 2, and 3, and 3. So you're going to have 3 moment equation. If you do 3 equations in the real numbers, frame, you have to do the same thing to this one. So you're going to have unit load. So you're going to have small m, small m2, small m3, big M, small m. So for moment equation, for the first part, here to here is 25. So the first equation is from 0 to 20 to x1 to 25. For this one, you cover everything. All you look at is this. For this one, you want to find a moment at this point. So you're going to put moment, assume going this way is positive. Moment at point m1 is equal to 0. Yes. So it's going to be this one nothing, nothing. So m1 is just 0.
Lee, what's the distance?
25 feet.
No, I'm saying
Here to here is 25.
I'm saying where you take the cut, what's the distance?
You see this one? Nothing along this members.
No.
So it's this.
Okay, so what if there was
Right here, like this.
No, if the roller was a pin, and then there was a reaction going up, what would be the distance from that moment to that?
You mean here to here?
Yeah, x.
25.
Would be X.
Yeah, x.
X.
Yeah, x.
I'll no go. Go ahead.
So this one's 0. So m1 0. So for second part, you make a moment equation in any point of this thing. So just do one here, and you set this distance is x2. So you're gonna have unified moment at this point. So you're gonna have here same thing is from 0 to 25. Before this 25, don't confuse with this 25 and that 25. This 25 is from here to here, and this 25 x2 is from here to here. So for this one, assume moment going this way is positive. 1, 2, let's go to 0. So for this one, if you want to find a moment at this point, you ignore everything from this side. So if for this one, you're going to have 1.0 going up, and times this distance, which is x2. Going this way is negative, so negative 19.5 times x2. Nothing here, or you have distributed load. So you're going to have 3 feet. So you're going to have, I'm just going, because when you convert this, it becomes a point load. So it's, and you find a moment at this point, so it's going to be positive. 3 times x2 times x2 over 2, because this distributed load times distance, you convert it into a point load, and the point load is acting at the center of this thing, which is right here. So this distance is x2 divided by 2. So this is moment. And then plus m2. So m2 is going to be 19.5 x2 minus 3 over 2 x2 squared. So for this one, you don't have to do everything from this side, because you put a moment equation from this side, so you only consider this side over here, only this part, and the same thing from 0 to 25. So let's put it right here. 0, x3, 25. For this one, same thing, turning this way is positive. Moment at point 3 is 0, 0. turning this way, oh, I'm sorry, 18, turning this way, it's going to be negative 18 times x3 minus, because n3 is also turning this way, so it's negative. n3, so your n3 should be negative 18x3. Yeah. So you have this. This three moment equation is for the real numbers. Now let's do the unit load. Same thing.
You don't take 19.5
Where?
for moment 3?
For this, like I said, look. You see, before I do this, first one, second one, third one. If I do this, I only consider this part.
So it's
Because this is the new start. You don't have to deal with all of those things.
so you're allowed to do that?
Yeah, you're allowed. I mean, you can do that.
'Cause that's what she did in class as well.
Yeah.
Okay, cool.
Because I mean, it's easier to do this when this side had nothing.
Yeah.
Because for example, if you have like 1,000 point loads, same thing. You do this way, that way it's the same thing. Because you still have a lot of things to do. But you only have one thing. Like this one, you can do that.
But I have two. The three parts shouldn't be negative.
No, but when you find a moment at this point, this is toward to this point, so you don't have to find it. All you have is just this.
So 18 times x.
Yeah.
You remember, like for example,
Yeah.
if you have a force acting this way, and this is your support, so By, Ba, you want to find a moment at this point. You don't do this point, because this point is toward
Yeah.
to your point. So you only, for moment, you only have, you only find this one. Same thing here. You want to find this point, so toward, you don't care about this one. So this one's done, so same thing for this one. Moment for this point. Turning this way is positive. Some moment equals 0. So you're going to have -1 turning this way positive, which is 1 times x1, and plus small m1. So small m1 is going to be negative x1. It's from 0 to 25. For the second one, this point, turning this way is positive. Sum of the moment at that point
Isn't
is in the
M1
zero.
positive?
Huh?
Isn't M1 positive, the small M1?
No, because you have to bring this to this side. So positive become negative.
Okay, remind me after the video, I have a question to ask.
Okay. And for this one, M2, you find moment at this point. 0 going this way, nothing. -1 going this way, it creates positive moment, which is 1 times 25. Why use this? 1 times 25. 1 times 25. And then plus M2. So M2 is going to be -25, and it's from 0 to 25. Because this one is from 0 to 25. This one is from 0 to 25. Yeah. So this is M2. For last one, same thing. You find this kind of moment equation, so you only deal with this part. So assume going this way is positive. Sum of moment is 0. So you're gonna have going this way negative. So -1 times x3. Also negative, minus small m3. Small m3 is going to be negative x3. 0 to 25. This one, it's not from 0 to 25, but it's from 0 to 25 because you do with this part. So here to here, not here to here. So now we have all the equations. So you can use this. Oh yeah, let me, before we do that. Like I said before, if you move a force, you have to add, if we move a force, you call that redundance. So you have to put back a force called 1. So your equation for that is going to be delta, this is AX, delta AX plus AX times FAX, is that how I call it? Or FAA is equal to 0. This is your equation. So for delta AX, you want to find delta AX. Delta AX, you're going to use this formula. A to B, big M times small m over EI dx. And for FAA, you're going to use AB small m squared over EI dx. So which one you want to do first? Let's do delta AX. So for delta AX, let me just copy it down. M1 is equal to negative x1, 0 to 25. Small m2 is going to be negative 25, 0 to 25. M3 is going to be negative x3, 0 to 25. So for delta AX, you're going to have, this is the sum. I'm sorry, I forgot to put it. So for this one, we're going to have, for delta AX, you're going to have, first, moment 1. So you're going to use big M1 times small m1 divided by EI. So, and it's from 0 to 25. So big M1 is 0. So 0 times anything is 0. So this one's gone. So for second one, for M2, so 0 to 25. For M1 or M2, you're going to have 19.5 x2 minus 302 x2 squared times small m, which is negative 25 over EI dx, plus M3. M3 is negative 18x3, and small m3 is negative x3 over EI dx. So if you do that, you're going to have, you just do the integral, check my answer if I'm wrong. So you're going to have 24968.75 93750. Yeah, this is this is that. So now let's do, should I just find the sum of this? Because I didn't do it.
If you didn't do it, just put equals to sum. Just
No.
don't even do it.
Yeah, I'll do it.
Okay, do it. I used the whole thing.
It's 1 3 1 3. Yeah.
Okay.
1 3 6 7 1 8 0.75.
This is for delta AX. Now you have to find FA8. So for FA8, you're going to have 0 to 25. FA8, we're not going to use big M, we only use small m. So take the small m squared, so negative x1 squared, EI, plus 0 to 25. Negative 25 squared plus 0 to 25, negative x3 squared dx, dx. So you're going to have 5280 EI plus 15625 EI plus 5208, wait, 08, EI. Arsenal, can you find the number for me?
Yes, sir. It's 26,026 041.
So now you have this number. You have this number. Put it back into the equation. Delta AX is
136718.
what? Yeah. So you want to find AX. With this sign, divide by that, so you're going to have negative 5.3 cubed. If this is negative, what does that mean? Come on.
Our assumption is wrong. It's
So
opposite.
this number is going this way.
Yeah.
5.3 cubed. It's not going that way, but this way.
Are we done?
No, not yet. So now we have this force.
Do you want to use that side of the boat?
No, it's fine, it's fine, it's fine.
Would you say Majid taking us out of the board?
Now, you know what? Let me just...
Like storing man half naked.
Wait, man, the roof is gonna fall off picture. I prayed in our
So
office.
you're gonna do something else?
The roof is going to give a rated F picture. Famous.
You guys don't know what this costs us.
So now... Now, we just find this force. In this case, if we only have 1, 2, 3 unknown, and we have 3 equations, so we can find a moment at this point to find all the reactions. So if you do that, you're going to find AY is going to be 19.5, BY is going to be 55.5, This one's going to be 12.7. After that, you have all the reactions, so you can draw your shear moment diagram. So for shear, you're going to have 5.3 going this way, so 5.3. Nothing, so straight line. For this one, you have 18 kips, so 18 minus 5.3, it's going to be go down to here. But also, you have 12.7 going this way, so you move this up to here, so it cancel out, so it ends at 0. You understand, right?
Yeah.
Because right here, you have 18 going this way. You didn't have anything here, but it doesn't mean there's no force to cancel it. This, going this way, is going to cancel out this force. Because when you draw the shear, the shear for this one is going to be straight right here. Straight like this. Right? So you're going to have touch 0. And for this one, at this point, you have 19.5 going up. So you can have 19.5 going up at this point. And then you have distributed loads, so 3 times 25, so minus this number. So you're going to have something n at here, which is negative 5.5. At this point, you have 5.5 going up. So here, bringing back to 0, so it's good. You see, right? Here, because you have distributed load, so 3 times 25, 75, so 75 minus this, it's going to be negative 5.5. But you know for shear, you have to end up to 0. At this point, you have 5.5 going up, so it brings this point up to 0. So it touched 0, it closed, so it's good. So for this one, you have 18 going this way, but you have 5.3 going this way. So this minus this, you're going to have something like 12.7. And then nothing here, so just bring it down. At this point, you have 12.7 going this way, so bring this back to 0. Positive, negative, negative, positive.
What was that number?
I'm sorry.
I don't understand why is the top negative for a triangle?
Yeah, that's
Oh, positive.
Okay.
Yeah, that's it. You know how to find the distance, this and this distance, right?
Yeah, a similar triangle.
So yeah, you draw a similar triangle. So this plus this is equal to this. You know the length is 25, so you want to find this. I mean, you know how to do it. I'm not going to do it. I'm not going to do it. I'm just going to give you a number: 6.5, 18.5. So this is your shear in cubes. Now, moment.
That's my shit.
For moment, 5.3 times 25. It's going to be 132.5. So straight. One, 132.5. It's up to here. At this point, nothing cancels it out. So that means you have to carry this because it's positive. You have to carry this into this. 132.5. So you're gonna have at this point. So 19.5 times 6.5. Check my calculation. I didn't do it right. 19.5 times 6.5 divided by 2.
63.
And then plus 132.5.
1 3 times 3.
132.5 plus that number. I hope I did it right.
What was the number? 1 3 times what?
1325 times whatever you just got.
Okay. So it's 195.875.
So yeah, so I'm doing it right. So bring it down because you have negative numbers. So I mean, yeah, you know how to do Moon diagram. So like this. So it will be negative 375, negative 1725. And this one didn't end at 0. So that means you have to carry this into this one. This is negative, so you start from negative. 317.5. And you have to find this area, so it's going to be cancel out to 0. Positive, positive, negative, negative. You know how to see it, right? When you see this one, you see from this side. So positive. From this one, you turn it like this, positive, and this one, this side is positive, this side is negative. That's why this is negative. So now you have your moment diagram. Now deflection.
This was
Positive. So you're going to have smile face. But remember, for this one, you have to look at it like this. Positive, negative. So smile face is like this. How are you going to draw a smile face? It's impossible to draw it like this, right? Because you have point of acting this way. So your smile face is going to be like this. Yeah, something like that. Smile.
Doesn't go to 0, right?
I mean,
Or deflection.
it changed. It doesn't matter. It doesn't matter. I mean, smile face. Positive smile face. So you're going to have smile face, and this is negative, so it's sad face. So you're going to have smile face and sad face. Smile face, sad face. Smile face, sad face. Positive, negative. And then for this one, sad face.
Sad face.
Like I said, for this one, you're looking at it like this, and for this one, you have to look at it like this. So sad face, you're going to have sad face like that. So it's going to be, I mean, it should be more. So you're going to have like that. So this is your deflection shape. Yeah. Let's just maybe take a look. I mean, I'm not sure the answer is right. Check it and tell me I'm right. So that's it.